Hi everybody, I am Josh Eisenberg. I am the lead scientist in natural language understanding at RD. Probably a lot of you haven't heard about RD, but RD is a startup in Los Angeles that makes virtual characters that you can talk to. The whole purpose is for entertainment and for having fun. Hopefully one of our characters and games will be released later this year and you'll be able to try it out. But the types of interactions we're working with are like very famous cartoon characters or very famous comic book characters that I'm sure all of you have heard of that I can't tell you about right now because they haven't been launched yet, but soon you'll hear about them. And what I'm doing is building out all the NLP and NLU tools that allow you to have conversations with them. So you see them on your cell phone, they appear on the screen of your phone, and you can have a conversation with them for like 3 to 5 minutes at a time. So I'm using my experience in NLP and NLU to get the characters to understand what you're saying. So that's partially why I've been focused on dialogue. At some point at RD, I realized that it would be important to be able to identify which spans of text in the things that users say to our characters represent events. Event and story are super related to each other. Like a story, some of the most simple definitions of story is a series of events that occur over time. That's like a super simple version of what a story is. I think that's E.M. Forrester's definition. Really, there's a lot more to story than that. There's lots of things that happen in the story that aren't just events. There's details, people give their feelings, there's flashbacks and flash forwards. Stories aren't always told linearly. Stories aren't always told by a reliable narrator, so the details can change over time. But something that's key to understanding stories is to understand events. And right now, through this work, I was working on getting the computer to figure out where in an utterance the events occur. And an event can be anything from an action that happens in the world or a state of being. Specifically state of beings that are describing people. So if I told you I feel sad or I feel happy, the happy or sad is a state of being. Whereas if I'm like describing the scenery and I said like the mountain has lots of rocks on it or the mountain looks green, for the purpose of this work, I wouldn't consider that a state of being because it's describing an inanimate object versus an animate object. Okay, so I'm interested in teaching computers how to understand stories. That's what my PhD dissertation was on, getting computers to understand where stories begin and end, what the point of view of the narrators are, what the diegesis is, and where stories actually occur in text. Stories are so important because people use them every day to describe, to share with each other, to connect with each other, to bond. People use stories internally just to kind of like narrate their own lives or to form like a model of what has happened to them and kind of decide what to do next based on their prior history. So stories are very important, and something that I've been working on for a really long time is getting computers to understand stories so that they could better understand people. So again, back to the scope of RD, like we're dealing with people talking to virtual characters on phones. So dialogue is a lot different than text, than just normal like novel text or scientific literature or other types of text. Like the way we speak is different than the way that we write. So since I was interested in teaching computers how to extract events from dialogue, I decided to see if there were any corpora for event extraction on dialogue. And I saw that there weren't. Like most event extraction corpora are newswire, like Time Bank, Meantime, and Kaggle even has a corpus. This isn't an all-inclusive list, but these are just some of the more popular ones. There's some that are based on social media, but still that's a bit different than text. I mean, than transcribed dialogue. Like Twitter is somewhat more similar, but there's just a lot more noise in Twitter data than there is in just normal transcribed dialogue. Like they have emojis and they have hashtags and ats and links, and it's typed out. Like it's not originally from people speaking. Like that's what I'm more interested in. Like a hypothesis that I had, which I somewhat prove in the next couple slides, is that the way people speak is like a totally different type of discourse than the way people write. So again, oops, I'm just gonna check Zoom, make sure nothing bad is happening on Zoom. Nope. Okay, good. Oops. How do I make Zoom smaller? This is annoying. Okay. Why is that there? Sorry about that. Okay. And then the last event corpus that I found was on biomedical text, which is very different than dialogue too. So there's all these event corpora with their own annotation schemes. A lot of them use TimeML, but none of them really did what I need them to do. None of them are on dialogue. But is dialogue really even that different than other types of text? So I did a comparison to back up this claim between Newswire from Reuters 21,000 corpus and the corpus that I made, the PEDC, Personal Events and Dialogue corpus, which are transcripts from This American Life episodes. So what I did was I compared the narrative point of view, which is how a narrator refers to themselves. So either first person or third person is what I'm comparing against. So first person, they use first person pronouns to refer to themselves, I, me, my, mine, versus third person pronouns. And then diegesis is the narrator's relationship to the story that they're telling. So if a narrator is involved in the events of the story they're telling, it's a homodiegetic narrative or narrator. Or if they're not involved, it's a heterodiegetic narrator. So I first tested it on the Reuters corpus. Less than 1% of all narrators in Reuters, which is Newswire, are first person. Whereas almost 60% of the narrators in the This American Life corpus were first person. So there's a lot more personal stories. And also for diegesis, less than 1% of the narrators or speakers in Reuters and news were first person, whereas over 30% were homodiegetic in This American Life corpus. And that makes sense because on This American Life, people are often telling stories that happen to them or stories that are somewhat adjacent to them in their lives. So these are more personal stories. Like people really talk about themselves when they're talking. Like talking is a way more personal form of discourse than writing things in the news or writing scholarly articles. Like most people don't use first person pronouns in scholarly articles. I do because I think it's, I don't know, an arbitrary distinction not to use first person pronouns. Like I was running experiments, you know, I'm going to tell you the story about the experiments that I was running and what happened. Like I feel like there's no reason to remove the scientist from it, but that's just my point of view in terms of like the writing style. So this whole chart is just to show that the discourse in the personal events and dialogue corpus is a lot more personal and a lot different than narrative, than Newswire discourse. And how did I do these experiments? Well, I used the point of view and diegesis extractors that I built during my PhD, published in this publication from Computational Models of Narrative, or sorry, Computing News Storylines workshop in 2016, 4 years ago almost. Where I trained up a program that can classify the point of view, and diegesis automatically based on the pronouns and based on the SRL parses, semantic role label parses for each event that happens. Like if the point of view classifier works by looking at the occurrences of, I think, 21 different pronouns, and train up a support vector machine on that. And I ran an annotation study, and we actually annotated the first 300 pages of a bunch of books from the corpus of English novels. And actually, and for the diegesis, the features were pronouns, but also we looked at every predicate and decided and looked at the arguments of the predicates. So if it said Homer ate the donut, eating is the predicate, the verb, and then the argument is Homer, like he's the person doing the eating, and then the donut is the other argument, is the patient. But Homer isn't a first person pronoun, so it's not homodiegetic. But if I said I ate the donut, I'm in like a first person pronoun, and I'm doing the eating, and it's the argument of the predicate, so that would count as a really good feature for homodiegetic. So this is just to give you a sense of how that kind of stuff works. And interestingly enough, I was able to get a patent on this work on the features, not like the code, because you can't really patent code. You could only patent ideas, which is kind of stupid. But you're able to patent this kind of stuff. So if you've ever taught a computer how to do something using a novel set of features, you can patent what those features are. It's really cool. Probably cost you a lot of money to patent it, but if you're into patents, go for it. Okay, so back to the data set that I built, the personal events in dialogue corpus. Actually, there's a question. I'm going to see if it's something I want to answer right now. So there's a question from Stephen McErney. Is Homer ate my donut homodiegetic? And yes, it is, because it's affecting you, like the narrator. All right. Okay, so personal events in dialogue corpus. So I decided to make this corpus because there were no event corpuses annotated for, or there were no corpuses of like transcribed dialogue that have been annotated for events. So I made my own. I also like I had a couple of months where I could basically do very exploratory research at Arty, where like I had a whole bunch of stuff built and I was kind of waiting for engineering to catch up. So I had time to do something that I knew was going to take like 3 months. I had 3 months to kind of do whatever I wanted at the beginning of the year, like before Corona hit. So this is event extraction was always something that I was interested in. Like it's kind of like the next thing that I was planning to do after my PhD. Like I can find where the stories occur in text. So now let's extract events so we can try to piece together plot. And since I'm interested in dialogue, because working at Arty, characters talking to each other, I decided to do this specifically for dialogue. And since my budget, I could only hire one annotator, Michael Sheriff, who was the co-author of my paper, and he actually did a lot of the annotations for my PhD work. He's a creative writing master's student at Florida International University, FIU, great writer and also one of the best annotators I've worked with. So I wanted to choose a subject matter that we would enjoy annotating, since a significant amount of our time was going to be spent annotating. And to me, annotation's a fun thing if you're annotating fun text. So I wanted to choose something that I enjoy, and something that I really enjoy is This American Life. If you don't know about it, This American Life is a podcast produced probably, like it's on NPR. They probably get some kind of funding from NPR. I'm not sure. And And it's just about everyday stories and also extraordinary stories too. So we chose 14 episodes from the last, I guess, 3 years. They cover things like race. They cover things like politics and feminism, love, reality, hate symbols like the Confederate flag, and dogs, because we all like dogs. So before we get into the details, you could find the data set at the link below or on the screen. You could also find it on my website if you don't want to type all that stuff. That website's at the bottom of the screen. Also, I was able to open source it with the CC BY license. I want to thank This American Life for allowing me to do this, because I just did this, ran the whole annotation study, finished, and then realized that I probably don't have the right to distribute it. So I just emailed them and they gave me the right to distribute it. So just to specify, This American Life holds the copyright of all the transcripts, but has given me the permission to distribute them. Like, their transcripts are available for free on their website. So you could download all of them, even more than what I have in my corpus, which is really cool. And I definitely encourage you to listen to the show. Like, if you're not listening, there's some crazy episodes about Corona and about the protests about George Floyd that are amazing. So definitely check it out. So just some stats on the corpus. So we trained on 1 episode, which I don't list here. But here's the 14 episodes that are actually in the gold standard. We have the episode names. We have about a little bit over 1,000 utterances. An utterance is when a speaker says something that counts as an utterance. It could be anything from one word, like saying like haha or hello, to like a whole monologue, which, like, I'm more interested in dialogue. So the utterances weren't typically that long because they're conversation, but in conversation, sometimes people take a long time to say things or use a lot of words to say something. Not really about time, but more about the length of words here. Okay, so an interesting thing to point out here is that in this corpus, about 3,700 of the words were classified as events by both of us, and about 13,000 of them were non-events. So event means that we agreed and we said that this is an event, and a non-event is we said it wasn't an event. And on the last column is Cohen's kappa for a binary classification problem. So just in case you're not familiar, Cohen's kappa is an agreement metric, which spans from -1 to +1, where 1 is perfect inter-annotator agreement and -1 is perfect disagreement, which means that if you got a -1, then everything that I said was an event, Michael would have had to say is a not event. So that would actually be really good too, but people strive for +1, everybody says, if I say it's an event, then Michael says it's also an event. So we did really well. Like, most of them, there was only one that fell below 80%, I think. Basically, it's considered that anything over 0.80 is considered almost perfect inter-annotator agreement. Like, we spent a lot of time adjudicating, so it's hard to say that it was almost perfect, but the results were really good according to the people who made up Cohen's kappa. I don't think there's anything else to say about this. Okay, this is kind of what the transcripts look on their website. So I want to point, I don't know if you could see my mouse, but under prologue, it has Ira Glass saying something. When I reached Eric Paul 3 weeks ago, he was on the road. In fact, it was his second day on the road, headed for Kansas, where he's from, to Washington, D.C. So that is narration. That's not dialogue. Like, the stuff that's not indented, that takes up like the full length of the transcript column, is narration. But the stuff under it, where it's Eric Paul's, Ira Glass, Eric Paul's, Ira Glass, that's dialogue. So we were only interested in that. So I only took that text. Didn't take the narration because it's a different type of discourse. Oh, I guess I could have zoomed in. Okay, so we're gonna kind of, in this part of the talk, do a more deep dive on the annotation stuff. So I'm gonna play for you a couple of excerpts from the episode, and I'm gonna show you my annotations and Michael's annotations, and then the gold standard, and talk about the decisions we made, because I feel like our event annotations might be a little bit different than most people's. Like, for one, it's totally different than TimeML. Like, I only had 2 to 3 months to do this work. So we didn't use TimeML, which is probably the most common event annotation scheme. We basically just surrounded what we thought were events in brackets. Like, to me, I only needed, for the purposes at Arty, like, I just want to know what spans of text make up events or states of beings. So I wasn't interested in finding participants. I wasn't interested in annotating causation. I wasn't interested in annotating all these things like durations of time, which are all important things, but really I don't need all of that like segmented away from each other. I just want to know what is an event. Like, it would have taken a year to annotate this if I had to use TimeML. Thankfully, we didn't do that. Like, I just needed to know what spans of text make up events. Okay, so.
Really? Yeah. When you look up at the stars, like, do you think about what they are? And the distances and stuff and all that?
No, not in a deep way.
I mean, it's so easy not to feel anything, but like, it's a crazy thing you're looking at. Just like how small we are and how big it is.
David tried to explain the feeling that he was having to me in a bunch of different ways. And the explanation that made the most sense to me was when he told me that he'd been...
Okay, so that's that. So there's 4 utterances there that we're going to go over, though. Really, then David, then Ira, and then David. So just a little bit of context. The episode's about Fermi's paradox, which is whether we're alone in the universe or not. Are there aliens or not? And David Kestenbaum is kind of depressed and saying that he's sad that, like, he thinks that we might be alone in the universe and he doesn't want to be, and he wants there to be aliens, but like, what are the chances of us seeing aliens in our lifetime, and what are the chances of them actually coming here, and all that stuff. So that's kind of what they're talking about here. Okay, so let's go over the annotations.
Really?
So the "oh really" had no event in it, so I don't show that one. So this is what I said. I said lookup was an event, like, it's kind of like a compound verbal phrase kind of thing. Like, some people might only annotate look, but in our annotation guide, which you can see at that link that I provided earlier, you can go to my website and find it. We annotate like those kind of compound phrases, like look up or look down or fall down, as single events. So when you look up, so look up is the event. Think. Yeah, so let's see what Michael did. So he did look up, think about, and what they are, and the distances and all that. So he said are was an event, and think about. And then for the final gold standard, so put the correct ones in green, just to have like a little visual thing. It's red and green. So we decided that about wasn't an event here. We just said that it should just be think. Because about is kind of more structural. Like, it's not really an event. It's just kind of like an it or an if or a is kind of word. And then we include the are because they're kind of like talking about like what something is or what, like, the meaning of something. So we don't annotate every time are shows up, but this time we did, because what they are and the distances. I don't know. It's kind of more about the meaning of what something is here. It's a little subtle. All right. Next, we both agreed in this one, so there were no nothing that we actually had to do. No, not in a deep way. So a way is like referring to the way that he thinks or doesn't think about the distances and stuff. So this is another interesting one. So for this one, I did easy, feel, looking at, and small, we are, and big. Or I guess Michael did big, and I didn't do big. And he didn't do easy. So there's a good chance to introduce like states of being. So easy here is like a state of being for how he feels. Like it's so easy not to feel anything. Like feel is clearly an event, but easy is a little more subtle because it's a state of being. Again, I did looking at, but Michael just did looking, and we agreed on just annotated looking. This is kind of like in the previous slides, think and think about. And we ended up taking out the about. So it's interesting because sometimes Michael annotates too much, sometimes I annotate too much. But when we adjudicate, we kind of come up with the best solution. So the think about here is very similar to the looking at. Like the at is more structural. It doesn't really give us that much more information. And small and big. So small gets annotated and big also gets annotated because they're states of being for animate objects, which are the people. And well, how small we are, it's a state of being for humans, and how big it is a state of being for the universe. And it was kind of subtle, but we kind of decided that the universe for this conversation was animate because we're talking about like the universe and all the beings in the universe and all the life or potential life in the universe. So we decided that it was animate.
Hey, Josh, can I challenge you here?
Yeah.
Isn't not to feel an anti-event? Feel might be an event, but it says not to feel here. So it's sort of an anti-event.
Right. So we...
More abstractly, how do you handle negators like that?
So we didn't do the negators, but we still do the actual event. So we still do feel. So like the actual like type of event it is gets annotated, but we weren't, like in the annotation scheme, we weren't annotating the negation words. Does that make sense?
Sure, just trying to understand your method.
Yeah. Okay, and then here's another example. Let me think of if there's, while we listen to this, I'm gonna think about if there's some other good examples for that. Okay, so this is another episode. It's about a guy who's opening up a new church, like a white guy opening up a church, I think in like a black neighborhood. All right.
You ready?
This is AJ Smith.
I'm this white kid with dreadlocks all the way down my back, with a scraggly beard, wearing like moccasins with holes in them, pants that had been patched up 1,000,000 times, flannels were ripped up.
Now, AJ, if a good day for him is to go sit in the mountains and just sit there by himself, that's a good day for him. That's kind of how he dressed.
Crunchy dude.
Yeah, yeah.
Yeah.
But he was a nice guy.
AJ actually brought a lot more than just worn out moccasins to the table. He was training at...
You ready?
This is...
Oops. Yeah, so that's this excerpt. We have like 4 utterances to go over. So we're going to get more into states of being and how subtle state of being is. And maybe we took it a little bit too far, but I think it works for my context at least. Okay, so the first one, I'm this white kid with dreadlocks all the way down my back with a scraggly beard, wearing moccasins with holes in them, pants that have been patched up 1,000,000 times, flannels ripped up. So we actually both agreed that white and kid were events. Not really like an event as like I shot an arrow, but more an event as in like a state of being. Like being white is the state of being here. Like it's a necessary detail in the story. And also the age is also kind of a state of being. So they're both separate events, because if it was just I'm white with dreadlocks or I'm a kid with dreadlocks, like they're both kind of separate parts of their state of being. With dreadlocks all the way down. So, and the word with here, I think got annotated. I'm actually going to try to describe to you the decisions we made before I show you the gold standard, just so I have to actually think about this on the spot. So with, I think the reason Michael annotated with is because it's kind of like saying they have something. So the actual event or process of like owning or having or possessing something is like with. Like I know it's kind of a very structural word most of the time, but here it actually like prescribes possession of a person, like a person possessing this trait, and a person is animate. So we are annotating all of the states of being for animate objects, which are people or magical objects. Okay, so we did the withs. Wearing, because you're wearing something that's an event. Moccasins with holes in them. So that one, I don't know if we actually ended up doing that in the gold standard. Let's see. And then patched versus patched up. I think we went with patched up because it's kind of like a compound thing. And flannels that have been ripped up. So the ripping is referring to an action that happened in the past, not really the state of being of the pants, which are inanimate. So I think that's why we did that. All right, let's see the final ones. So patched up and ripped up got through. A white kid with dreadlocks all got annotated with a scraggly beard, because with there is ownership, wearing moccasins with holes in them. So that second with, or the third with there, the moccasins with holes in them, doesn't get annotated because that with is like the moccasins have holes. So it's like the moccasins are inanimate. So it's an inanimate object with holes. So it doesn't get annotated. So as you can see, this is complicated. Like within the same sentence, with gets annotated twice as an event, and once without an event, once as it's not an event. So it's kind of subtle, but it's important to get this right. So we spent a couple months like annotating and adjudicating a couple times a week remotely, because I'm in LA and Michael's in Miami. So that's fun coordinating that. But it's definitely fun. Like it makes you read things differently. Like when you're reading novels on your own time or just talking to people, you think about the relationships between the words and the phrases that you're saying more often. It's kind of like meditative doing this kind of work. Like I think it's really good to, even if you're, quote, the lead scientist or like whatever title you have, like it's good to annotate. Like it'll make it easier for you to figure out how to classify something if you first do some annotation. Okay, that's weird. I must have, oh, and then, so these three, I put them all on the same page because we got perfect agreement on these three ones. So I kind of wanted to do that to show you that like sometimes we did get sentences in a row where there were no mistakes, you know, so these three had no mistakes. Let's go over them. Now, AJ, a good day for him is to go sit in the mountains, just sit there by himself. That's a good day for him. That's kind of how he dressed. So I just want to point out that like the pronouns he and him aren't annotated in this, because like earlier, like I guess it's here, like dude or guy get annotated, but him isn't really a state of being. It's just like a co-reference here. So now AJ, a good day. So that's like the day is what's it called? Like an event. Like the day is a span of time and it's a good day. Like really, I think these should have been two separate events because good is like the state of being for it. But okay. For him is to go sit in the mountains. So sitting in a specific place, just sit there by himself. That's a good day. That's kind of how he dressed. The second one, crunchy dude. So crunchy is just like kind of the describer of the person, like the state of being. And dude is also a state of being too. Yeah, no, yeah. Ooh.
Sorry, you're good.
Sorry, it said I was muted for a second.
No, you're good. Sorry.
Okay.
Hey, Josh, since I'm talking,
Yeah.
let me pose one of the questions here. What's the difference between events and verbs? They seem the same. And for that matter, you have adverbs in there as well. Things like, well, guys, crunchy is an adjective.
So there's a difference between events and verbs. Events are things that happen in the world, either that like affect the world or like the states of being that like represent how people are. So there's a whole bunch of verbs here that aren't events, like is in the first one. And let's see. So like pants that have been patched up, like have doesn't really give that much information. It's just saying that like this happened.
Hey, Josh, can I suggest I think these are great examples of the annotations. Do you want to move on to the next part?
Sure. Yeah. So there's a difference between events and verbs. Like event is more of like a semantic class of something actually happening, whereas verbs can be more structural. All right, so let's talk now about the features for automatic event extraction. So I'm extracting sets of features for each token of each utterance. So for the first token, I extract a whole bunch of things. The second token, I extract a whole bunch of things. And then I'm training a support vector machine to actually classify whether each token is an event or not. So I'm framing this as a simple binary classification problem on each token, given information about these tokens. I'm sure people are going to say, why don't you use a sequence-to-sequence model? Why don't you use deep learning? Why don't you use something that's better for sequences? Honestly, didn't have time for that. I was just trying to do something quick and to just show whether these features that I'm interested in are good at describing or good at classifying events or not. I'm sure someone can take this data set and make a better classifier using a more advanced method. But here I'm showing you like what features actually work or not. And I'm not really doing anything that terribly fancy. Like I am gonna eventually make this a bit more fancy when I have some more time, but this is just to show you, you can get up to almost 70% F measure without doing anything that fancy. Like I'm sure you get the rest of the 20% by using something that's more context dependent. But I'm just showing you what works without crazy deep learning stuff. All right, so one of the features is verb classes. So I'm sure some of you are are aware of VerbNet. VerbNet, it's kind of like a fork of WordNet. WordNet is an ontology of words. VerbNet is an ontology of verbs. So one of the cool things about VerbNet is that they classify all of the, hold on, I'm gonna make it cooler. I just got hot. Sorry about that. So VerbNet has 278 different classes of verbs. So where they have like verbs of similar semantic meanings in a single class, and there's 278 of those classes. So quick example, the verbs for slurp, chomp, and crunch are all in the same class. The class is chew. So chew has, this is a screenshot of the VerbNet website, has all these verbs within it: chew, chomp, crunch, gnaw, gum, lick, masticate, munch, nibble, peck, pick, and teeth. are all within the class for chew, and they all kind of mean the same thing. Like you're doing something with your mouth, you're chewing on it, you're munching on it, you're pecking. All these things really mean the same thing. So it's a way to simplify, like it's great that you have all these words to express yourself because they all have slightly different meanings and connotations and make you feel different things when people use it. But currently for a computer to understand it, it's easier if we break down these verbs to one of these 278 classes. So instead of having to know like thousands of things, the computer really only has to keep track of 278 different things in terms of the verbs. So the way I do this is I use the It Makes Sense word sense disambiguation tool. It's out of Singapore from the I think NUS lab, National University of Singapore. I've been using that code for a really long time. It's awesome. It works pretty well. Also, I'm doing this all in Java. Like I know a lot of you are probably using Python, but I use Java for the NLP stuff because it seems to me that there's better tools for Java for the NLP stuff. Maybe for the machine learning stuff, there's better tools in Python, but I think the actual NLP stuff is a lot better in Java. So I use the word It Makes Sense word sense disambiguation to actually get the word sense for each word. So it determines the meaning of each word according to WordNet. So it gives you a sense key or a sense set or something like that, sense ID. And then I map that to VerbNet, and I have a map for WordNet keys to VerbNet classes. So once I know the meaning of each word and know which words are verbs, I look it up in VerbNet, and then that's a feature. So the verb class feature is a vector of 278 features. It's a binary classification, or it's a binary feature. Really, I use -1 and +1. 1 meaning this word. So like, let's say we're dealing with the class chew, and this is verb class number 39. So if chew appears in a word, then, or if a word is a part of the chew class, then there's a +1 in that feature vector. And if it's not, it's a -1. So usually like it's a pretty sparse vector for the verb class stuff because each word usually only exhibits one verb class. Like I think some words can take up to 3 verb classes, but usually like 90-something% of them are -1s and only one of them is a +1. All right, some easy features, part of speech tags and named entity tags. As someone pointed out, there's a lot of similarity between verbs and events. A lot of verbs are events, but not all verbs are events. But it's still useful to know when we're dealing with verbs. So one of my feature sets are part of speech tags. So I use Stanford Core NLP, the part of speech tagger, with their whichever model's better, but a little bit slower is the one that I used. So that's a feature vector of I think 21 or 22 or 26 things. I forget how many part of speech tags there are. And basically only one element of that vector will be +1 and then the rest will be -1. And named entity features. I was interested in this because I thought named entities would be a good anti-feature. Because if you're a named entity like Microsoft or like someone's name or place, it's usually not an event. But actually it wasn't that good of a feature, honestly. Like I think those things are picked up in part of speech tags. It's just a hypothesis that I had. But I'm glad I ran the test, honestly. Semantic role labeler based features. So I already went through the Homer ate the donut example where the predicate is eating, the agent is Homer, and then the donut is the argument or the patient. So I went a very simple route. I probably should have went like a more complicated route here, but I had 2 features here. One for whether a token was a predicate and one for whether it was an argument. So simple 2 binary features. It's a +1 if it's a predicate and -1 if it's not a predicate. And then the second feature is +1 if it's an argument, -1 if it's not an argument. This feature didn't really have that much effect on things. Like I thought arguments would be possibly good anti-features and predicates would be good features, but it didn't really help that terribly much. But really, the SRL that I was using is a lot more advanced than like the way I was using it. It's a really cool SRL. It's called Path Lstm. It's a open sourced. It's on GitHub by a bunch of great researchers in Edinburgh. And the cool thing about this SRL, like I don't know about any other SRL that is, so if somebody else knows, let me know. This SRL parses into FrameNet. That is kind of like VerbNet, but like on steroids and a million times like more, like maybe like 5 to 10 times more detailed than VerbNet. So like you have 1,200 different semantic frames in FrameNet, whereas in VerbNet you have like 278. So you really get a lot more information. Like they have like instead of just chew, it will probably have like 5 different classes for like how they're doing the chewing and what's doing the chewing. Is it being chewed on something edible, or are they chewing on something inedible, or are they using it, or are they doing it like figuratively? So FrameNet is awesome, and this SRL is awesome. I wasn't using it to its full power because it's hard to do that and a lot of time. But in the future, I might try to do the 1,200 FrameNet and parse into that, similarly to how I was parsing into the VerbNet frames, VerbNet classes. All right, and now, so that's the features. I was extracting those things for each token. So some machine learning protocols. I experimented with undersampling because there's like a 4-to-1 distribution of 4 non-event tokens for each 1 event token. So when you're using support vector machines, if you have such an unbiased data set, it can like, it'll sometimes just classify everything as the majority class if a big like bias, which here it's like 4-to-1. So I did a thing with undersampling where like I wanted it to learn evenly from the events and the non-events. So I sampled the non-event tokens for like if they're like, let's say there's like 80 events, 80 non-events and 20 events. I would randomly choose 20 non-events to learn from. I know random sampling isn't the best for this. Like I know that it's good to use like entropy when choosing what non-events you're using, what majority class examples you're using when you're undersampling, but I didn't do that for this. Things still worked out pretty good, but that's a technique that I'm interested in, using entropy to do this kind of selection, to choose kind of like some of the best choices or the feature vectors that best represent your class. So the whole point of undersampling is so the SVM doesn't get overwhelmed by all of the non-events. I simulated context. So really when you're making this kind of decision, when a human does it, they see the whole sentence. So what I was doing, instead of just showing the feature, showing the SVM, the feature vector for the word we're making decisions on, showing it for the word before and after also. So yeah, that's like a cool way to introduce context to a support machine. I know it's kind of a hack, but it works to some degree. I know I should be using sequence to sequence method or something that's more better for like sequence stuff, but this works pretty well for support vector machines. Again, use support vector machines. Pretty sure I was using a linear kernel, but check the paper. It's on my website to the details, and just doing binary classification on each token of dialogue. Here's all the experiments I ran. My computers were both working overtime and the guest read overnight for a long time. There's a lot of numbers here, certain types of meaning out of it, but I'm going to point out one set of numbers for the best experiments. So the best features ended up being part of speech tags and verb classes. Like by themselves, part of speech tags got a 62% F measure on events and got a 56% F measure on events. But when you combine it, you get a 67. So it's really cool that like the two of them are like work together, and you get more information using the two of them than either of them had by themselves. It's really cool. Also really cool that you could get almost 70% F measure only using a support vector machine without really doing context in a good way. Good job, support vector machines. Like, they're super old technology, and I'm happy they still work pretty well. So again, part of speech tags and verb classes were our features. And I kind of I first do it without undersampling and trigrams. That's the first row. Then the second row is only undersampling. So we get an improvement of like almost a full percent, like 0.7, 0 or 0.7%, like for the points or F measure. Also, I'm using F measure, precision, and recall here, where some kind of equation based on the true positives, true negatives, false negatives. I'm using F measure because it's more honest and accuracy when you're dealing with such unbalanced classes. We're more interested in the event class. Like in my work, like I want to know what the events are, so I could do operation, so I can I know what the events are, and then I can use this to a transition for the state machine, so then the virtual character can know the right thing to say to you. So I'm more concerned about what's an event than what's a non-event. But the results for the non-events are great. Like that's 88% measure. So that's really cool. 68% for the events, though. Still some room to grow. So first I did the undersampling experiment. Then I did the trigram experiments where I give the support vector machine context of previous features and the next word's features. And then I put them and combined, and the results are a bit better. So when you add undersampling and trigrams, the results go up 1%, like almost 1% in F measure, from 6.98 to 67.94. So 0.04 away from a whole percent boost, which is pretty cool. Another cool thing about these results, which is good for those people who are like in industry where sometimes it's more important to minimize false positives and other times it's important to minimize false negatives. Like your two types of mistakes, false positives or false negatives. If you do undersampling, or first look at the normal results. Like we're going to be paying attention to the precision and recall in the event columns. So precision, without undersampling and without trigrams, precision is 85% and recall is 55%. With undersampling, it flips. So your precision goes to 55 and your recall goes up to 87. If you just do trigrams, back to the original one, back to as if we weren't doing we weren't doing undersampling. So the trigrams don't affect the order, or not magnitude, just the range, I guess you could say, of the precision and recall. But when you do it again, last experiment, it flips it again. So I forget if precision or recall, if precision is monitoring the false positive rate or the false negative rate. But if you're concerned with doing one or the other, you can use this as a tool to make your precision higher than recall, or your recall higher than your precision. Because sometimes you want more false positive or less false positive, and other times you want less false negatives. So this is something that I hadn't seen before in my work, but I thought it was really cool, and it worked. It happened like this in most of the experiments. You could look at the paper if you want more details on actual experiments. But yeah, this is like the overall thing, like kind of confirmed the thing people know, like part of speech tags are important, but also verb classes are important. Like not all verbs are events, and a way to encapsulate that or get the computer to understand that is by giving verb classes. Like verb classes aren't just useful for this. back during my PhD, I had a story extractor where it can look at a paragraph of text and decide whether there's story content in it or not. And one of the features is looking at what verb classes are used during the paragraph. So verb classes are essential to stories and events. Like this goes to show you, like they are like kind of like an essential element or a measure kind of events and stories.
Josh,
Okay.
Can I do a time check? Oh, it looks like you're wrapping up because we do have a bunch of questions.
Yeah, this is my last slide now. Hold on, I just need to reset audio process. Give me 1 second.
So folks, while Josh is doing that, if you want to be voice enabled to ask your question, use the raise hand feature.
Okay, can you guys all hear me now? Can you hear me?
I can hear you.
Okay, cool. Yeah, so let me just finish up. So the main contribution is I open source this corpus. It's there on Artie's website and on my website. I encourage you to all download it, check it out, get better results than me, and publish about it. Like, I'm not saying I'm the best person to do this problem. Like, probably one of you are. So go forth and get good results and publish about it, and then I can use your classifier. And I ran a bunch of experiments. Like, I put that second because I think really the data set here is the key contribution. My experiments give you good suggestions on where to start looking and what to do next. You know, they're probably not the best features, but they're a good set of features. All right. Thank you for paying attention, and I'm down to start answering questions.
Let me pose the first question for you from Jaida, and I'm going to interpret it. Jaida asks, so the name Homer, that goes back to much earlier in the presentation, can also refer to I as first person noun. Is there a significance of that relation? And I would more broadly say, are you doing co-reference here?
Hold on, I'm trying to pull up Zoom so I could actually see you.
Yeah, so let's stop your share if that's okay.
Yeah, sure.
And now you are on the screen. So question, and I voice enabled Stephen McInerney, so after you answer this, he can ask his questions live.
Sure, so what was the question again?
Well, the name Homer can also refer to I as first person noun. Is there significance of that relation? And I was wondering more broadly about co-reference. Since you had verb classes, I mean, sort of in a way, co-references people.
So I'm not doing co-reference here, but you totally could if you want to. Like, can you just repeat the question one more time?
Well,
so the name Homer.
The name Homer can also refer to I as first person noun.
Right, but they're also, it's being like actually used in a third person manner. You know,
yeah.
Like the choice to use the word Homer is the choice to use third person.
Okay.
Yeah.
Stephen, do you want to ask your question?
Yeah, sure. Yeah. Can you hear me?
Yes.
Yeah.
Sure. Yeah. Thanks for your talk, Josh. I wasn't trying to hamster you to death on the definition of homodiegesis or homodiegetic. I don't know how relevant these are, but it just occurred to me the way you defined it. It doesn't seem to be binary. So if I added a bunch of follow-on questions to what I'd asked earlier. So I was saying, for example, if I said I was going to eat the donut, but Homer ate it first, arguably, probably still homodiegetic. Taking it to extremes, anyone could have eaten the donut. Homer, Lisa, Krusty, maybe hypothetically me if I was a Simpsons character, but Homer ate it. Is that even homodiegetic? Probably not. And the last one, which I think proves it isn't, if I'd lived in the 16th century, I might have been a pirate, versus if a person had lived in the 16th century, they might have been a pirate. The latter is not homodiegetic and the former is equivalent. So is homodiegesis, is it even crisply defined? Does it matter?
Yeah, like, it depends on the granularity of the diegesis that you're going for. Like, you could say whether the book is homodiegetic. You could say whether the sentence is homodiegetic. You could talk about whether each event is homodiegetic or not. So it really depends on how big of a context you're talking about. But if you're involved in any of the events, like if we're talking about on the paragraph or the sentence level, if you're involved in any of the events, then, and by you, I mean the I pronoun, then it's
Yeah.
homodiegetic.
Yeah, I guess the hard one would be like the works of William Burroughs, where typewriters start talking and eating people and stuff. Yeah, that's probably gonna.
Yeah.
It's gonna not. Yeah, it's gonna be out there. Anyway, thanks for your time.
Yeah. No, it's interesting in those contexts too, because it's harder for the computer to understand. Like it needs more context than literally is given.
Or Alice in Wonderland, which is said being called psychedelic 17th century fiction written by a mathematician.
Exactly.
Inspired by laudanum. Anyway, thanks very much, guys.
Yeah, you're welcome.
We had a question in the Q&A. There are many transcribed interviews. Did you consider using transcribed interviews?
No. I feel like interview is also like its own form of discourse, opposed to like dialogue, which is more it's not always as like one-to-one. Like sometimes one person's asking questions, but at least in dialogue, or the types of dialogue I use, both people kind of ask questions to each other. So I thought about it at first, but also I wanted something that I would enjoy annotating.
Okay. We had I'm going to give it a shot here if, no, all right. We had a question from Will Linkmeyer. I'm going to read it for you, and then Bob Krovitz had a question, and if Bob is still on, I'm going to voice enable him. He is. So Will Linkmeyer asks, what data structures did you use to organize events in natural language? Was it a bag of words type approach or bag of events? And then second, after extracting events from text, does your model carry homo or digasticism?
Okay, so the first question about like data structures, none. Like I'm just using like, let's say if like there's 10 words in an utterance, each word has a binary classification. So it's either an event or not an event. And then can you repeat the second question?
The second half was, after extracting events from text, does your model carry homo or hetero? I can't pronounce this.
Diegesis.
Digasticism.
No, diegesis.
Yeah.
They might have spelled it wrong. No, but because I'm not using diegesis in the classification, I was just using that as an example of why dialogue is different than Newswire. But I could just run my diegesis classifier over it, and then that's a way to know whether it's a homodiegetic event or a heterodiegetic event by like first doing the event classifier. So then you know which spans of text make up events, and then you run the diegesis classifier over the sentence. And then if it's a homodiegetic sentence, then you know that these events are homodiegetic. Like usually homodiegesis is kind of like the minority thing. Like it's the interesting thing, it's a personal story. So that's the thing that you're like looking for more often than not.
Okay.
Yeah.
Bob Krovitz, you're on screen now. Why don't you go ahead? You had a couple of questions.
Yes, I have two questions, actually three. One question is, when I looked at the results from part-of-speech tagging and verb classes, part-of-speech tagging had high precision but so-so recall, and it was the opposite with the verb classes. And I was wondering if you could say a little bit more about where the verb classes were capturing things that were not captured by part-of-speech. That's one question.
Okay.
The second question is
I'm not sure because it's been a while since I've done like a really good error analysis, so I'd have to look at it. But at least from my instinct is that verbs, it was helping, like the verb classes was helping the classifier distinguish between like structural verbs like is, was, are, be, and like verbs that actually have like more semantic meaning of like acting upon the world. So I think it's that.
Okay. I was also wondering about the impact of IMS. What was the impact of word sense disambiguation?
So that allowed me to get the verb classes. Like I wouldn't have been able to get the verb classes if I didn't have It Makes Sense. Like the way that I was using is that like I use IMS. So now for each word, I have a WordNet sense key. And then I could go from WordNet sense key to VerbNet class.
Okay.
I'm sure there's probably more accurate word sense disambiguators, but it's just the one that works really well and quick for me right now. But if anybody knows of a good Java one, I'm open for suggestions.
I was also wondering if you ever thought about using plays in order to get discourse.
So interested in that, but not as interested for my application, because like I am interested in like off the cuff conversations, like people are talking to people like are just talking to their phone, so it's not really like rehearsed, you know, it's off the cuff. Whereas like a play or even like dialogue in a novel is its own type of discourse.
Okay, thanks.
Yeah.
All right, next up, I've promoted Christopher Brew for a couple of questions.
So can you hear me well?
Yeah.
Yes.
Great. Okay. So thank you for pointing out that in a realistic setting, the weight might not be the same for false positives and false negatives.
Yeah.
I wondered two things about that. One is, have you tried doing an ROC curve to get a sense of the whole character?
No, I haven't.
And the other question which comes with that, which is, what's your best guess about the realistic payoff of false positives and false negatives for some use case that makes this valuable?
So, okay, so I'm thinking about my use case where I'm doing conversations, and let's say it's some kind of like conversation with like a virtual like cartoon character. Let's say like you're talking with Charlie Brown, something like that. And Charlie Brown like asks like, what did you do over the weekend? So for Charlie Brown to understand what you did, he needs to extract like know which portions of the speech are events. So for that, if there's a high amount of false positives, then you're going to be getting a whole bunch of things that aren't events annotated as events. So for that, I would want to minimize the false positives and have more false negatives possibly. So like as long as I get one of the events correct, then Charlie Brown is going to be able to like respond to you and be like, oh, you went to the beach, great. So for my application, it's that, but I'm sure that there's others where you would want to minimize false negatives.
Thank you.
Yeah.
Good. Isabel, you're up next.
Hi, I just had a question about the corpus creation. I think it's a
Yeah.
very interesting corpus, and I was wondering if you have developed any annotation guidelines as to, you know, in case others were curious about either augmenting or supplementing, you know, your already developed corpus.
Yeah, so if you go to my website or the website for the arty.com/data/personal events and dialogue, I think that's the link. But it's easier if you go to research-josh.com and go to the bottom to the corpus area. So in there, I have an annotation guide, not as detailed as most annotation guides. And honestly, I probably should edit it to like account for all of the things that we came up with during annotation, because we trained together, and then each week we would meet after we did an episode and adjudicate together. So we kind of got more of an understanding of what to annotate just by having conversations with each other, you know? So a lot of that like wasn't like captured, but it would have been interesting to like record our annotation meanings, you know? I'm sure that would be useful for a lot of people. But you could go there and you could actually get the data, get the raw data, and get the annotations and go on. But if you want to annotate more and have any questions, definitely email me, because I'm definitely interested in expanding the data set.
Sure. In your guide, do you provide examples and use cases kind of from what you remember from your own analysis? Or I guess
there's lots of examples. There's lots of examples in there, but you could also, like, a good thing is to look at the actual annotated data, because from there you can kind of get a set, like by looking at the raw data, you can kind of get a sense of like what we think are events and what aren't events. Like it's probably one of the more subtle things that most people aren't doing is we were only annotating states of being for animate objects. because I'm not so interested in knowing like how the rock is unless it's a talking rock.
Yeah, I think I'm curious just because I work mainly in like biomedical information extraction. So the way that we use events are often with trigger of words and so forth. And this corpus is really cool. It's really different from other types of text that I use. So thank you. I know that there's other questions, so I'll hop on.
You know, I just saw a reference in the last day to event extraction specifically for biomedical sources. It's not my specialization, so I didn't notate it, however.
Yeah.
Okay.
But it's, even though biomedical like seems more complicated, like I bet in some ways it's easier to do it because you're only expecting like certain types of events to happen, you know? So
yeah,
it's
I think
cool
there's
problem.
often rules that we can use, but oftentimes it is, you know, back and forth, especially corpus creation can always be very complex. So
totally.
Thank you so much.
Yeah.
All right, we have Joe Toplin.
Hi, Josh.
Hey.
I am curious about how your work might fit more into the work you're doing to create software where you can talk to a character. And you started to talk about it a little bit when you were talking about asking Charlie Brown or talking to Charlie Brown. Could you kind of give us a big picture of how that component and other components might fit together to generate an entertaining dialogue exchange?
Yeah, so I'll say a couple things about that. So the way that we're doing it at Arty is different than what you're seeing at a lot of like text generation companies and people that are doing like automatic generation of text. Like we're
GPT-3.
Exactly. Like I'm taking like if GPT-3 is all the way over there, I'm doing the approach that's all the way over here. And the reason for that is that we're dealing with like really famous celebrities or famous cartoons or like just famous IPs. So we can't have Snoopy and Charlie Brown saying like something racist or sexist or anything. So we're not cutting people out in terms of writing. Like we're using people and like real authors and people who like would be writing for these IPs anyways to write the actual interaction kind of like in a really advanced state machine, like a super advanced discrete finite automata machine. The way the NLP comes in is that I'm building tools that take what the person says either to the phone or types into the phone and extracting a bunch of things depending on what state we're in. So I might use the code that I built for the event extractors to look at your dialogue and look at the events, and then maybe use some embedding space to figure out what type of event you're talking about. And if you're talking about like going somewhere, then the character might ask about like the specifics about how the trip was, or if they're talking about specifics with like eating events or those kinds of things, then it brings up like a whole type of conversation about food. So I'm basically just using, like I'm developing like a general tool set of like NLU feature extractors that serve as kind of like the transition function from state to state. So it's a very classical approach to a complicated problem, and like the complexity in what we're doing comes in like the interaction design of the state machine, and also the NLP and the NLU tools. Like sometimes I'll break up I'll like create word vectors for each word in an utterance and then use that for a transition. Because if sometimes you could do the entire utterance, sometimes you're just interested in knowing the vectors of specific words or the event words. Sometimes the verb class is enough for a transition too.
And what do you use for word embeddings to get the word embeddings?
Sometimes just WordNet. I mean, sorry, not WordNet. Word2Vec, like Google's thing. Like,
right.
It's like really not that complicated. Like sometimes BERT, you know, like it depends on the situation.
Okay.
Yeah, you get pretty far with WordNet for this. Because like really, like you just need to capture some bit of semantic meaning. Like I don't need everything. I don't need to understand everything, but if I can correctly understand part of what you say, then I can do the correct transition.
Thanks.
Yeah.
Okay, well, I think that's, let me start my video again. I think that's it. So thank you very much, Josh.
Yeah.
It's been great having you here today.
It was really fun. Thanks for inviting me.
So I will reshare that if anyone would like to give a talk at a future meetup, we do have the next one scheduled and actually the one after that. You can send me a note by email or you can message me on the Meetup platform, and then within a few hours I should have the video of this program posted the NLP XING YouTube channel, so you can view it there. And then our next program is on September the 10th on dText with speakers from LinkedIn, so I hope you all can join us then. So we're going to end the program today, and once again, thanks Josh, it's been great to have you, and I'll see everyone next time.
Yeah. Thanks again. See you, everyone.